Okay, so nagdilita na undang the coupling capacitors and the bypass capacitor. So we call this one the bypass capacitor because we have known na pwede i-bypass ang RE, no? Para mas sayon ang analysis sa AC na domain. But of course, na siya effect sa frequency response amplifier. So these are the external na capacitors and external capacitive na external capacitive na phenomenon. But we also have internal, no? Internal capacitive element, capacitive effects. So basically, di maging siya element. So for our BJT, even sa FET, in between the terminals, siya collector, emitter, base, in between the terminals, nanay malag virtual na capacitor diya, no? So kung natay capacitance meter, na ma-measure nga capacitance between collector and base, no? We call this one CCB, capacitance between collector and base, nagyapon between base and emitter, CBE, napod between collector and emitter, CCE. Yeah. So these are the internal capacitances. Yeah. Okay. If atong i-take ang definition of capacitance, it's the buildup of, it's the allowance of pag-store sa energy due to electric field, no? So electric field is generated man sa any metal na ay distance apart, no? So mo naman ginang ang definition sa capacitance. If natay duha ka metallic element, metallic na mga devices, no? And na gap between them, insulator, air, or whatever between them. So na capacitance. So the same gapon dire sa mga terminals, sa mga metallic terminals sa atong devices, no? So in between the terminals na capacitive elements. So we have external and internal. So right now, we should know that the external capacitors define the low frequency response of the capacitor. Of the amplifier. Sorry. Low frequency response. Meaning, unsa nga particular measurement, particular value sa nga frequency at the lower end sa spectrum ang i-allow nga ipapass through sa amplifier. And the internal capacitors and capacitances determine the high frequency response. High frequency. Okay? Wala lang, no? Maybe in more detail, more computative detail, next meeting na to ni ma-cover. So sa itsura sa frequency response, no? How do we visualize what the frequency response is? Actually, kato equalizer earlier, no? Frequency response to siya. Okay? So X and Y axis gapon. But this time, medyo naay kanang siguro challenge, initial lang nga challenge sa pag-visualize ani because naanad mong ta time domain, no? Time domain ang x-axis. So this time ang x-axis is frequency, the frequency. And the y-axis could be volts or power or gain, no? Gain. So frequency is measured in hertz and gain is measured in dB. And more on that later, dB or decibel. So, ang frequency response, ani, so zero gyapon dire. The closer the frequency is to zero, of course, the lower it is. And the farther, the higher the frequency. Okay? So, one example of a frequency response that we will be encountering is something that looks like this. So this is an example of a frequency response. So what does this mean? No? Again, hindi na siya time domain class ha. This doesn't tell us na off siya during this time and on siya at this time. No. But dul-dul gyapon ato, this particular signal or this particular signal is composed of different frequencies man. Ang kanilang set of frequencies ang i-allow niya ipapass through, no?
Parang filter lugar siya.
Yeah, filter na. Nakagin filter nga topic. Sa asa? Wala pa?
Sa music lang, sir.
Sa music,
general.
Okay. Kanang general nga paggamit sa term nga filter. Pero actually, maabot kita gapunta na pohon, filter. No, pero yes, ang filter lang, namagdaya po yung filter nga ani, no? Ang most common magud na filter kay low pass filter o high pass filter o low pass filter, no? But more on that soon. Di pa karon. So let's say for example this is 100 hertz, no? So 100 hertz and kani is 10 kilohertz. So yeah, anything below 100 hertz is dili ipapass to sa amplifier, dili ipapass to sa system. So if this is an audio na system, anything below 100 hertz will not be audible. Anything above 10 kilohertz will also not be audible. So ang iyang ipapass to lang is parts or the frequency sa signal in between from 100 hertz to 10 kilohertz. And so ang sa y-axis, this is measured in dB, no? Meaning let's say for example lang, ang gain sa atong amplifier is 100, no? 100 iyang gain. I-convert pa na to dB, dila ba? Later maka-learn ta on pag-convert to dB. Okay. So example 20 dB, no? So this is 20 dB. Meaning ang mga frequency dire nga parts would be amplified fully by the amplifier, no? Kaning duol na sa atong critical frequencies, these frequencies kaning akong gisingle out 100 hertz and 10 kilohertz, we will be calling these frequencies as the critical frequencies. Any frequency close sa 100 hertz or 10 kilohertz will experience an increase and decrease in gain, no? So again, ang y-axis is gain, meaning kaninga part dire, the frequencies closest to 100 hertz ang mga frequencies to the right of 100 hertz will experience an increase in gain. Anything below 100 hertz, decrease in gain until mabot ang point nga 0 na ang gain, no? So this is 0 dB. So any signal na 0 dB ang measurement dili siya mo pass through, no? That's why dili siya mo pass through because zero ang gain. Dili siya i-amplify sa amplifier. So the same gapon sa right side. Okay? So balik sa to dire. Sa tong slide. So atong i-translate what I have just discussed. The frequency response then of an amplifier refers to the frequency range in which the amplifier will operate with negligible effects from capacitors. Yeah, kay amplify man fully sa atong amplifier. So walay effect ang capacitors sa signal, no? And device internal capacitance. This range of frequencies can be called the mid-range. So sa to akong notes kanina. So generally kani nga mga frequencies will be calling these as the mid-range frequencies, meaning walay effect ang capacitors sa ilaha, walay effect ang external and internal capacitors. As you can see sa frequency response, full ang pag-amplify sa amplifier sa ilaha, full na gain ilahang ma-receive, in this case 20 dB. At frequencies above and below the mid-range, capacitance and any inductance, giday inductance gyapon, but wala may coil dire, so wala, no? If ever naan, hapon to effect. So generally, at frequencies above and below the mid-range, capacitance will affect the gain of the amplifier. At low frequencies, the coupling and bypass capacitors lower the gain. At high frequencies, stray capacitances, morning mga internal capacitances, kaning giterm as stray capacitances associated with the device, diba? Device terminals, also lower the gain. Also, cascading amplifiers limit the gain at high and low frequencies. In the same way before, we've known na kung ipang-cascade na itong mga amplifiers, multiple stages, mo naog ang gain, di ba? Same gyapon dire. Mas mo narrow, I believe, ang frequency range if mo cascade ta og mga amplifiers, no? Well, not necessarily dahil, no? Pwede ma-improve ang frequency domain, a frequency response. Pero general lang siguro yung statement ng i-limit niya. Okay, so yeah, mag-limit lang yun di ay. Anyway, next term, most commonly associated with the frequency response is the Bode plot. So E is stress, Bode plot. A Bode plot indicates the frequency response of an amplifier. So sometimes when we use the term Bode plot, kung ito ang ginapasabot ng iyang frequency response, and vice versa. We can only visualize a frequency response through a Bode plot. So the horizontal scale indicates the frequency, and the vertical scale indicates the gain. Frequency is measured in hertz, and gain is measured in dB. So what is this dB? Lagi ko an. Wait, ako kita pa sa slides. Lagi define ang decibel. Okay. Define na to ba? So frequency again is measured in hertz, gain is measured in dB. Previously, unsay unit sa atong gain sa electronics 1 class? How do we measure gain?
Sir, di ba walay unit kay i-multiply raman na to siya sa input voltage para
Very
makuha ang
good.
output voltage.
Sakto. So Thank you for remembering it. That's correct. Ang dB, ang gain before, we have learned unitless, diba? Unitless. So, karon nganong ang gain now is in dB. So, what is dB? dB is shorthand for decibel. Basically, the bell is the measurement for sound intensity. But ang bell daw is a much larger nga unit. So nag-prefer sila ng mga engineers na gamiton ang decibel, no? Malagod gyapon meter, centimeter, di ba na decimeter, then ay millimeter. So the same gyapon, no? Naman gyud siguro centibel or millibel, pero hindi ko sure kung haba na siya practical nga use. So more practical ang decibel, mas ginagamit niya siya, especially sa electronics engineering. So decibel is not only used in this one, frequency response, or gain. We'll soon further learn, especially sa mga comms na subject, that decibel is also the unit for losses, no? Okay, ang opposite na sa gain kay loss. Okay? So, before, malagamay lang nga trivia. Before, when we had cascaded amplifiers, no, to calculate for the total gain, di ba? Ito ipang multiply na to ang gain ni amplifier 1, ni amplifier 2, ni amplifier 3. If naka-convert to dB ang mga gains, ang pag-determine sa total na gain is just as easy as adding, no? So, anong wala man kayo challenge sa pag-transfer from multiplying to adding, no? Anong mas sayon lugar ang adding kaysa multiplying? Mas sayon na siya gamiton ang decibel because kung ato nang i-consider ang losses, no? Mas libog, no? Mas libog kung i-calculate na to ang overall response sa system, considered ang gain of losses dito, kung dili siya naka-dB. Kaya kung naka-dB man good, ang mga gain is ipang-add lang rather than multiply. And ang mga losses is ipang-subtract lang rather than divide. No? Mas intuitive kibali ang pag-add of subtract o gains of losses. So you could observe this one sa pag-calculate. Let's say, for example, sa example, how much signal would be measured sa receiving end of a communications na system. So kung sa mga losses sa kanang klase nga particular system, no, mukaon og loss ang transmission medium, ang wire or ang air, ang wireless nga medium, mukaon og loss ang mga antenna, no, ang mga effects sa environment, ang weather, no. So those losses will be considered sa calculation, and mas easy kung naka-decibel ang mga losses, mga gains, kasi just as it's as easy as adding and subtracting the gains and the losses, no. Pero this time, di pa man nato ni ma-cover sa electronics 2 ang gains and losses sa kanang context. But decibel is the unit of measure for gains, no? For the amplifier gain particularly. So how do we compute for the decibel, no? Decibel, how do we convert the gain, no, from a unitless factor to decibel? Okay, so to convert a gain from unitless to decibel, remember that gain or voltage gain is atong designate ang letter A, subscript V, no, AV. Convert, sometimes dili lang AV ang gina-designate sa gain, but pwede gyapon ang letter nga G, no? Gain. So yeah, so pareha na sila, which is equal to voltage out over voltage in. Yeah, sakto, no? Voltage gain wala, voltage out over voltage in. So this is gain nga unitless. Unitless. So how do we solve for the gain in dB? Ana. So sa gina-subscript o dB ang letter G or ang gain para mabalaan nga in dB gina siya. So sa wala na. Assume na siya nga dB. No? So dali ra kayo, no? Dali ra kayo pag-convert to decibel ang kuan. Just use this formula. 20 log of the gain ng unitless. Yan lang. Okay? So this is the voltage gain. More common na type of gain is the power gain. Of course, different ang voltage gain o power gain because power gain is measured in even though power gain is measured in unitless siya, no? Pero to compute for the power gain is power output over power input, no? So whatever is the output power, divide lang siya sa input power. So to compute for the power gain in dB, use this formula. 10 log PO over PI. Sa G gyapon eh. If kabulot daan, ang kaninga G is power gain. But if medyo labog, so nga na. I think mo naman yung formula for the computation from decibel to from unitless to decibel. Now, with respect to the body plot, why will we be using decibel? Because it's convenient. Because it's convenient to use the decibel. Why? Observe sa x-axis, no? Dili siya linear scale, right? Nawa ha. The distance from 10 hertz to 100 hertz is the same as the distance from 100 to 1,000 and the same ang distance from 1,000 to 10,000. So dili siya linear. So this is a logarithmic na scale. Logarithmic na scale, not a linear scale. Because kung linear, yan yung linear, no? 10, 20, 30, 40. So we all know that. So uniform ang distance from first point to second point, from second point to third point, so on and so forth. Pero kung logarithmic, it's not like that. Okay? So, ang pattern sa distances is, of course, logarithmic. No? 10 to 100, 100 to 1,000, 1,000 to 10,000. So, a factor of what? 10. No? There's a factor of 10 from one point to the next. And for us to use this type of scale, dapat ang x-axis man yun, no? So, dapat ang y-axis pod is naka-dB sa, naka-logarithmic pod na scale. That's why we will be that's why we are converting the gain from a unitless factor to dB. No? So kani dire naka decibels na sila. Okay. So cutoff frequency, what is the cutoff frequency? So the same sa kung visual earlier, this one. No? So ang cutoff frequency sa kaninga example is the 100 Hz and the 10 kHz. So how do we know what is the cutoff frequency? No, kay kung tanaw nato asa siya nag-increase o decrease, dili man fixed, no, or dili man static ang atong frequency response. Okay, unta kong yan nga na defined good. But ang ato labang frequency response is increasing and decreasing, no? Pwede siya more steep, pwede less steep, pero still increasing, decreasing siya. So dili siya abrupt na pag-increase or decrease. So the mid-range frequency range of an amplifier is called the bandwidth of the amplifier. No? So ang length, no, or ang span sa mid-range frequency or mid-frequency is called the bandwidth. Okay. This is like exactly the same but synonymous na siya. So ang ang measurement sa mid-frequencies or mid-range frequencies ang bandwidth. Okay? So synonymous as lang duha, of course. So this is also how, technically, this is how we also use this word in an everyday fashion. No? Kanang bandwidth bitaw, bandwidth sa atong internet, bandwidth sa signal. Dili na siya nakuha, no? Dili na siya nakuha nga term sa frequency response sa particular nga device. Okay? So ang bandwidth is, we could also define the bandwidth as the difference between the upper limit sa critical frequency, cutoff frequency, I mean, and the lower limit, no, sa cutoff frequency. Diba? Okay, dire ang F2 is muna ang FU, no? Upper frequency. Ang F1, this is FL, lower frequency. So ato lang i-minus para makuha natong bandwidth. Though it does not tell us, no, that knowing the band, dili na siguro mag-differ ang bandwidth o mid-frequency. Knowing the bandwidth actually does not tell us unsa nga set of frequencies iyang i-pass through. Pwede man good na ang bandwidth is, for the sake of simplicity, kasi the bandwidth is 3 Hz. Pwede man good nga ang lower limit frequency is 4 Hz. Pwede po nga ang upper limit frequency is 7 Hz. Diba? So ang ipapass through sa atong amplifier is from 4 Hz to 7 Hz. So ang bandwidth niya is 3 Hz. Pwede sad na iyang ipapass through nga frequency is 20, no? From 20 Hz to 23 Hz. Pwede nga na. So ang bandwidth aning second example is 3 Hz. Ang bandwidth sa first example is 3 Hz gyapon. Yes. So the bandwidth only tells us how large is the range of frequencies, but it does not necessarily tell us what those frequencies are. So kinahanglan pa nato tan-awon sa body plot unsa tong mga frequencies. So that is the bandwidth. The bandwidth is defined by the lower and upper cutoff frequencies. Okay. Cutoff. So how will we define cutoff? So daghan-daghan ba nis lang a set of frequencies? Okay lang sa kaning nga part, no? Medyo defined naman nga point. Okay, kay nag-straight naman na siya diha. But how about from this point to this point? The same po sa pikas, no? From this point to this point. Yan na. Asa ani nga set of points, okay, ang atong cutoff frequency. Kani ba siya? Kana? Nganong kaniman? Nganong dili kani? Nganong dili kana? Okay? So, how will we define the cutoff frequency? The cutoff frequency is any frequency at which the gain has dropped by 3 dB. Okay? So, where the gain has dropped by 3 dB. So, for example, ang gain sa atong amplifier for which ipapasto niya ang mid-frequency is 10 dB. Okay. So, 10 minus 3, ay lang ng 10, medyo define lang kayo. Let's say, for example, 90 na lang, 19 dB. So, 19 dB. 19 dB na eh. Kana. Or should I say kana. Okay. So, 19 minus 3, wherever nag-drop daw siya og 3 dB, 19, 18, 17, 16. So, nadali ang 19 dB. So, asa siya nag-16 dB, muna siya ang cutoff frequency. In this case, the lower cutoff frequency. Now, why negative 3 dB? No? Why a drop of 3 dB? Or negative 3 dB din siya actually. Di man ito pwede mo yung ang drop is negative 3 kay double negative na. O asa nag-reflect ang negative 3 dB. No? So ano negative 3 man? Because if ato na i-convert from dB back to unitless, if you have your calculators, common siya no, power, so 10 log unitless gain. I'm not wrong. 0.5 ni siya. No? Negative 3 divided by 10 anti-log. Yeah, more or less 0.5. Or in other words, where the power has lowered by 1/2. Okay? Another term ani, tanong ako din sa akong notes, no? Cutoff frequency is where power has dropped by half. Okay? So for example, ang gain sa amplifier is 10 dB. No, 10. No, unitless, 10. Kung unsa nga frequency nga signal na ang gain na lang sa amplifier is 5, no? That is the cutoff frequency. Or the power, the same sa slide, has dropped by 3 dB. Or maasa mag-reflect ang negative 3 dB. So for example, kato kanina, kung ang gain sa mid-range frequencies is 19 dB, kung asa mag-reflect na ang gain is only 16 dB, Kung sa ito nga frequency, that's the cutoff frequency. Any frequency at which the gain has dropped by 3 or has dropped by half. So for example, kani, no? Sakto kani. 0.707. Ah, 0.707 kung voltage gain. Okay. Kung power man no? For which the power has dropped by half. So kung voltage, -3 divided by 20, 15, and log. Sakto. Okay. Mabutang pa tayo taglahip gila yung definition doon. The power has dropped by half or the power has dropped by kung dB, power voltage, pwede. Power or voltage. Kung unitless nga gain, when the power is dropped by half, or when the voltage has dropped by 0.707. So muna ang value. No?
Hello, sir.
Excuse me, sir, nakamute ka.
Nakamute ka, sir.
Ano saan nag-stop ang akong audio?
Sa ko, sir, kay mag-cut off sa 0.0707 voltage.
Okay. Hindi naman ko kadunong kung asa ko. Pero sige lang. Oh. Anyway, so, okay naman ka kung audio ron.
Yes, sir. Madunggan na, sir.
Andun ka na. Sige, sige. Okay. .707. Basta kung kuan, nag-proceed naman kuan to dili, no? Basta kay kung that's how we calculate for the cutoff frequency. Kung kano saan nag-drop og 3 decibel ang gain, no? Whether power or voltage, hindi naman mag-matter, no? Basta dB nga scale atong gamiton, hindi na mag-matter kung power or voltage atong gain. Basta nag-drop siya og 3 dB, wala siya, diya mag-start ang cutoff frequency. So if you convert na to siya to power or voltage, kung power, it is when the power is dropped by half, no? Or 0.5. Kung voltage, where it has dropped by 707. That's why makita na to this 707. Okay, this is AV man di ay, no? Voltage gain. If power gain ni, kung dapat ni 0.5 power gain. No? Yan na. So anyway, let's try to practice. No? Let's try to practice converting from lag to from dB to gain, and vice versa. Sige daw. Kaya dali naman ang pag-perform og lag sa calculator, di ba? How about anti-lag? Familiar ba tatanan how to use anti-lag? For example, dali lang maning 1, 2, 3, 1, 2, 3, no? Di na ito na i-solve. Dito data this number 4. Let's try to solve for number 4, ABC. Calculate the power gain in decibel for each of the following cases. So, if output is 100 watts,
13 ang A, sir.
13 ang A. Power, no? So, 10 lag. Okay, 10 lag. 100 divided by... Nakuha ba sa... okay. Kumulay ni amplifier mo din, no? 100 divided by 5. So, 13. Okay, thank you. 13 dB. How about the second one? 100 milli over 5 milli. The same ba, di ba? 100 milli. Milli. 13 dB. Ang C, $100 milli divided by 20 micro. Mas 137 dB. Kung ano sa tanan? Did everybody obtain the same values?
Yes, sir.
Yes, sir.
Okay. So, dali naman, di ba? What if bali? No? How will you convert 37 dB back to unitless gain? Performing anti-lag. So, ano sa calculator? Would like to point out sa class. Of course, hindi na ito makuha ang 120. No? But if ito i-convert ni 100 milliwatts divided by 20 microwatts, that's a gain of 5,000. No? Kaya kabalo naman ta sa given input o output. So what if dito given? No? Let's say, for example, 88 dB. How will we convert that to unitless gain? Kasi nakabalo. Anyone? Or this is the first time pa?
First time pa na.
First time pa na ako ni sir.
First time pa, sige.
Bro.
Pero,
Nakuha na akong 5,000 na gain sir through shift solve na approach.
shift solve. Pwede lang na, no? Pwede lang siguro shift solve. Pero nabi ng anti-lag sa calculator. Kung asa ang lag, ang shift, anak mo na anti-lag. Sa ba? Saan camera? Muning lag, di ba? Ang anti-lag actually is 10 raised to that number. No? For example, 88 dB. 88 is equal to 10 log the power gain. So first, i-divide sa into 10. No? Okay. Coefficient man sa nawala po kubalik ba?
Balik na ka, sir.
Balik na. Kani, okay na? Share screen. No? So, okay, balik na. So, wala niya ang anti-lag. 10 raised to the power of the dB divided by 10. No? So, naka-divide na nagtendaan ng 88. So, 8.8. 10 to the power of that. Muna siyang anti-lag. So, yes, 10 to the power of 8.8 is nakuha niya 630 0.96 times 10 to the 6. Oh, so, kuha na again. Ako lagi kayo. Okay. So, 20. Okay, sakto na no? So, kung ato i-perform na balik sa 37. So, 37 divided by 10. 10 to the power of answer is 5,011. Approximately. So, okay na itong 5,011. Alright. So far, any questions sa pag-convert from unitless to dB, then dB to unitless? Okay na? Sabtan ba?
Yes, sir.
Alright. So, in question number 5, determine dBm for an output power level of 25 watts. What is this dBm? Mubalik yapon ni siya sa comms ninyo pohon. So, if ever man malimtan ninyo ni, okay ra, no? Balik ko na yapon ni. Pero dBm is so nato ako ni pag-define. Practically speaking, pwede na ipang-operate ang mga dB o dBm, no? Sa communication system ang good. Common ni siya, no? Di manon mass, but common gyapon ang dBm. In a sense nga, remember that dB is gain, di ba? Gain. If natay gain, that means power input of output over input. Okay? So pwede na to ma-express ang ihang dB ani. Okay? 10 log of that one lang. But what if atong given is dili gain but power, input power, no? So sa question number 5, that's 25 watts. 25 watts. Base ato nabalaan lang, ha? Could we convert this to dB? Yes or no? Pwede naman po tayo sa chat, no, kung gusto mo answer. Based lang sa ito nabalaan gyud karon, ha? Could we convert this to dB? Yes or no? Mo na ang given.
Yes, sir.
Yes. So unsa man atong i-divide? Remember, ha?
Kailangan
10
output.
log, di ba? Power input, output over input. Average. I'm not sure kung say hindi mo pasabot, Marco, pero need og PO, okay? No, kay need og output. So yes, dili siya directly ma-convert, no? That's true kay we've known gud biya bago lang, no? Just recently na ang dB is unitless na gain. So about this one, no? About sa communication systems, if this is a transmitter, usually the transmitter is characterized by its input power such that pag abot sa receiver, pila na lang, no? Pila na lang iyang signal output. Okay? Let's say mo agi siya og mga subsystems, no? I don't know. Maybe antenna ni siya. So na yung mga losses dire. Okay. So how will we convert this 25 watts to something that we could use? Wala man tayo output pa. Kaya ang question nga ni dire is, pila ang output? Convert na to dB. Wala man tayo output. Ang output may taonon pa. So there's this concept that we call dBm, no? Using dBm, pwede na nato ma-convert into something usable ang atong input power without output pa. So the same given formula, walay na lahi na kalayan sa walay difference sa main nga formula, 10 log gihapon. So if the gain is in dBm, that is because we have used a reference in this case, dili ni siya PI gani. Power lang na siya. Ako man maingon pod nga kuan gyud ay, no? Output ni siya ang 25 watts. It doesn't matter man. Okay. Kani input siya sa system pero output siya sa source. Output sa source, no? Pwede naman nato yun. Technically, di naman matter, no? Di naman matter input or output siya. What matters is that given power is divided by a reference value of 1 milliwatt. So, i-divide na to 1 milliwatt ang atong given. So, in this particular case, example, determine, number 5, determine dBm for an output power level of 25 watts. So, the formula for this one in dBm is equal to 10 log 25 over 1 milliwatt. Okay, so 1 times 10 to the negative 3. So how much is that one? So 25 44. 25 divided by 1, negative 3. 10 log ans. Yeah, 44. Thank you, in here. So I hope everybody got 44 dBm. No? So ang dBm mag-signify na this value was calculated using a reference of 1 milliwatts. Ano? If ever malimtan na yun yung point, okay lang. Pero if we have dBm, then if we have a loss of 2 dB, let's say for example, pwede na ba na siya i-operate? Lahi man og units, pwede. No? So ang total response ani is 42 dBm. So pwede i-operate, no? Pwede ipang-add or subtract ang mga dB o dBm. But make sure na ang final output is naka-dBm, no? So trivia lang ni siya as of this point. Ma-cover na gyapon ni again. So, but yes, the answer is 44 dBm. Number 6, 2 voltage measurements made across the same resistance are 110 and 220. Calculate the power gain in decibel of the second reading over the first reading. No? Instead of 10 log dB, we just use 20 log dB. No? G is equal to 20 log second over the first. So 220 divided by 110. 10 log 2. 20 log 2. So 6 dB. Same game as question number 7. Input and output voltage measurements of VI and VO are made. What is the voltage gain in decibels? How much? Notice that VO is volts and VI is millivolts. No? Sir, millivolts man ni sir. Dili ba dBm ang output? Dili, no? Dili dBm. Kay given man ang duha, no? Pure man siya nga gain, voltage gain. So, ay lang gid siya dBm kung gi-divide na to siya og imaginary. No? We do not use the term imaginary, pero ato mo guna siyang gigamit nga reference. But if we use the reference na 1 milliwatts, that's the time nga dBm ang gamiton. But even if millivolts ang given, dB gyapon ang output ani, okay? So, pila answer 68, 68 dB. 20 log ha. Yeah, sakto. I hope everybody also got this one, 68 dB. That's correct. Last na siguro because it's 6 p.m. na. Okay. The total gain. Ay na ning 8, malamanig puzzle, no? Algebra maning nga puzzle. Oh, number 8. Number 9. If applied AC power to a system is 5 microwatts at 100 millivolts, and the output power is 48 watts, determine the power in decibel. Okay, dali na siya. Power gain in decibel given man po ang input o output, no? The applied power is 5 microwatts and the output power is 48. So it's just 48 divided by 5 micro. Then 10 log. Okay, power man. So 10 log. 70. Yeah, 69.8 man. So 70 is good na. The voltage gain in decibel. If the output impedance is 40K. Di mo ni magamit nga kuan gyapon, oh. This is just for formality, 40K. Hindi man sila magamit. Pwede siya gamiton. Kung naman tayo 70 dB. Try na to. 70 dB, 70 dB is equal to 20 lag daw. Input mo ng 100 volts, millivolts, no? VO over 100 millivolts. I hope correct pa eh.
I-shift sub din siya, sir.
Ay, voltage kay decibel mo day, no? Sorry. Ay, isa, no? Ay, sa iba akong gibuhat. So, dili the same in this case ang kwan. Magamit din yung 40K dahil class. Sorry. So, ganyan formula sa power. Power is kung given voltage of resistance, I squared R, V squared over R. No? So V is equal to, so ideally given output square root of 48 and 40K. Okay. Square root of 48 times 40K. 1385.6 volts. So muna itong VO. So ito akong pamagi ganyan class. Ang 70 dB power gain na ni siya. Dili na siya mong voltage gain. So if nanatay VO, dahil na masolve ang gain in voltage gain in decibel. 20 lag VO 1385.6 over VI 100 millivolts. Yeah. Mga 83. Nasa mangyana.
Yeah, same, sir.
Input impedance. Solve ni. Okay. Input resistance ni. Gamit ni nga formula gyapon, no? Naman tay input power o input voltage. So R is V squared over P. Input impedance. $100 millivolts over 5 micro.
$2,000, sir.
2,000. Okay, 2,000. 2 kilo ohms. Output voltage. Nato nila, nasolve natin kanina. So power gain in decibel 70 dB. Voltage gain in decibel is 83 dB. Input impedance 2K. Output voltage na lang. So nato kanina 1385. Okay. So that's how we convert from unitless power gain to dB and vice versa. Questions so far? None? If there are none, so we'll end here. No?